Greetings, Algebra Express students, and congratulations on surviving that onslaught of syllabuses during your first week. So today we're going to go through Merecek chapter 2.2. It's called Use a Problem-Solving Strategy, and we're going to work through a few word problems. So I know word problems are not everybody's strongest suit. So I think if we can work through them and take a little bit of time and define what we're talking about, I think that will probably clean things up a bit and probably get you on the right track, or at least get you a good amount of points if you show a good understanding of what you're doing, hopefully. And so we're going to go over a few word problems or applications involving percentages. And so before we even jump into this thing, which I guess we could do technically, I want to talk about like what a percent is. And so they talk about a percent of a base is amount. So they have PB equals A. So P times B equals A. That's an okay way to define things, but I typically think of things defined as a percentage. And so the percent, if we solve for the percent, this is a percent times base, we'd have to divide the base over. So I think of a percent, oh, they don't use age. So I think of a percent as a amount over a base. And so what a percent is it's some number that we're comparing to 100. It's a comparison of ratios. And so I think maybe the best thing to do is start plugging some numbers in so you can see a little bit about what I'm talking about, and a little bit about how they're defining things. Because both ways I think will help you understand and grasp like what a percent is a little better. And so what number is 30% of 90? And so if we see that word percent, that's the thing that's over 100. So we're thinking about 30 over 100. And then we're looking at this other number here, 90. And so we're thinking 90, is that an amount or is that a base? And so the key word here, I think, is this word right here, of. And so of means that's like the population that we're drawing from. That's the sort of population or base amount. And so 90 should be your base amount. And so what we want to find is the amount. And so to solve this, I think the first thing I'm going to do is convert this to a decimal. So usually you're going to convert your percentage to a decimal when you do your word problem. And so we convert that to decimal. That's 0.03 or 30. Sorry. Nope. That's 0.30. Make sure you convert things right. 0.30 is equal to some amount over 90. Okay. And I know I probably put the whole word, but this is just a variable. And so if the amount is really confusing you, this is just like A over 90 is equal to 30%, right? And so how do we solve for A? And so this is A being divided by 90 is equal to this. And so to solve for A, since it's being divided by 90, we have to multiply both sides by 90. So we're multiplying this side by 90. We're multiplying, I can't write numbers today, but here we go. We're multiplying this side by 90 as well. And so we multiply both sides by 90. And so 0.30 times 90 should give you 27. And this over here, if you have to, you can put it over 1. And so we have like 90 over 1. This should simplify out. And this side should just be my A. And so what is 30% of 90? Well, 30% of 90 is 27. And so that might be one way, that is one way you can think about it. That might not be the best way to think about it. To be honest, I think their way might be a little better on this one. Percent of a base is equal to amount. And so the first thing, we're plugging in the percent. So I've kind of already said it, but if we're plugging in percent, we're talking about 30%. We said 90 was the base, and now we're just on that last line that I had in the previous problem. So this way is a little quicker with the problem that they give us here. Okay. The next one, 4, says 63 is what percent of 70? So I want to think about it maybe both ways. We want to know the percent. And so percent is some amount over a base. And so this one I think might be a little more straightforward with the way I have the formula started. And so the percent is amount over a base. And so we're going to basically throw that into a calculator and figure out what that is, which I believe gives you what, 0.90 as a decimal, or you could say 90%. Okay. Thinking about it their way, they have percent of a base is equal to an amount. You'd have to do some plugging in and a little bit of solving to do it their way, I think. And so we want to know the percent. We don't know what that is. The base is the 70, and the amount is the 63. So you'll have to do one step. You notice this is multiplication, so to get rid of this, we have to divide by 70. And if we divide by 70, we get the same thing that P is 3 over 70. There we go. Or the 90% when we convert it to a decimal, convert it to a percentage. Okay, so that's part 4. And I kind of said it. Well, I definitely did say it. A percent is a ratio. And so if you want to know what sort of number a percent is, you have to know the base, right? To know the amount when you were talking about percentages. And so you can really kind of like manipulate people by saying things like it's only 3%, right? And so if we're talking about 3%, we really got to know the base to even know what the heck we're talking about. Because if we're talking about 3% of, like, I don't know, the class is about 20 people, you'd be talking about what, like 6/10 of a person. That would be almost one person if you round it up, right? That might be one person. But if you're talking about like what, 3% of what I do? I did 300 million is what I did in my notes. Let's do that. So you're talking about like 3% of 300 million, which is around the U.S. population. That's like 9 million people. So you really got to know the base and to compare what you're talking about. So you can kind of manipulate people by saying it's only 3%, right? But 3% could be really small. It could be really big depending on what you're talking about. So you really got to know the base to know what sort of risk you're taking, right? So Marco earns a return of 8% per annum on his mutual fund. If her investment is $12,100, how much has he earned after 1 month? So a bit horribly worded, but let me jump back. I just jumped through this, didn't I? So what we're doing here is simple interest. And so they give us this formula, I equals PRT. And so I is interest, P is principal, R is your interest rate per annum. And this word annum just means per year. Like think about like maybe annual. T is your time in years. So let's recap this problem again. I'll read it once again. Sorry, got a little excited and jumped ahead. Marco earns a return of 8% per annum on his mutual fund. If her initial investment is $1,200, how much has he earned after 1 month? And so I want to like just start with like that first information they give us. It's 8% per annum. and the initial investment is $1,200. So if we're talking about 8%, as I said, we're talking about 8%. We need a sort of base number to know what sort of amount we're talking about. And so if we're talking about 8%, what are we talking about 8% of? Well, the thing they're taking the 8% of is this investment here. And I think most people, this first problem I think is kind of straightforward. And I think most people just like kind of thinking this through probably could just like not even look at this formula and kind of solve it. And that might be like part of the reason why I got a little excited with this problem. I don't really think we even really need to look at the formula to solve it. And so if we think about it, this is 8% of this 1,200. 1,200. And that should give us 96. And so what does this 96 represent? Well, this is $96 in interest that they're earning each year. Okay. And so if I asked you like how much were they earning in 5 years, I think most people would just like throw this in. They would say, well, they're earning this much per year. We would have to multiply that by 5. They would be getting 96 5 times. And so if we do 96 times 5, we should be getting something like 480. So this is not what the problem's asking. But this is where they're getting that formula from. It's equal to the percentage, what does it say? I got things a little backwards, but this is the commutativity property, right? It's equal to the principal times the rate, the interest rate, times the time. And that's what the PRT stands for, right? Principal times rate times time. And so let's go back. Let's actually answer the thing that they're talking about. And so in problem 1, we can just go right to the formula if you just want to go right to the formula and just start plugging things in. That is something you can do. But I like to give a little bit of reasoning behind like the structure of what they're giving you, right? And so our principal here, as I've said, in problem 1, our principal is the 1,200. I keep on saying 12,000 on. It's 1,200. And the rate, the interest rate, per annual interest rate is 8%. So converting 8% to decimals, you have to convert it 2 spots, right? And so converting 8%, we want to go the decimal place here, and we want to move it 2 spots. So we have to fill in a 0. So that is something that some people find difficult. Don't mess up your spacing. Always move it 2 spots. I did it earlier, I believe, and almost messed that up. So it does happen with everyone every once in a while. So we're all a little bit guilty of it. And now we want to talk about time. And so this is the weird sort of thing that they throw at you in problem 1. So let's go back up and maybe take a glance. 1 month. Okay. And then here they say time in years. So how many years is 1 month? Okay. So if we're assuming each month is equal, I'm just going to go with 1 month is 1/12 of a year. So that's kind of an annoying aspect that they threw at you in this problem. But this is going to calculate my total interest. And I think we've already done part of this. So this amount would be what, 96? And we have to divide that by 12. I believe the number that I'm getting here, 96, when I divide by 12, should be 8. And so we're talking about an interest of $8 per month. And so this is problem 1. And so for problem 2, they're going to make us do a little bit more solving. They like to ramp things up a little bit with each problem. I already know before I even use this problem, they're giving me the formula I need to use. So I can write that down already. I equals PRT. My interest is my principal times my interest rate times the time in years. So this says Alice is offered a loan of $1,000 to be paid back at the end of 5 years, along with $400 in interest. What is a simple interest annual rate? So they give us a lot of information. They give us a loan of $1,000, 5 years, and $400 in interest. And then the question that they ask is, what is a simple interest annual rate? And so the variable that they're asking for is the interest rate, which would be the R variable. Okay. So if we want to solve for R, we could do it symbolically, or we could plug in numbers. It works either way. So let's just, I think maybe just plugging in what information they give us might be simpler than working with symbols for a lot of people. So let's try it maybe that way. And so if she's offered a loan of $1,000, so what is this $1,000? Well, it's a money amount. So there's only really two things in this equation that are money amounts that are left, either my interest or my principal. This is time. And so that would be the loan amount is your principal. So that is the $1,000 going into my P. My R is the thing I don't know. My T is the time in years, which they give us 5 years. So I think there's only one thing we can plug in there. And the only other thing we need to plug in is this I, which is interest. So how much interest are they going to get? $400 is the thing left here. So now we're solving this for R. So 400 equals 1,000 times R times 5. So I think maybe the best thing to do, there's a few ways to do this. This is all multiplication. So we know multiplication has that commutativity. We can sort of move things around, just multiply kind of whatever we want here. So let's do what? 5 times 1,000 is going to give me 5,000 R. And this is equal to 400 on this side still. So I have 5,000 R equals 400. If I want to solve for R, this is being multiplied by R. So if I want to get this by itself, I have to divide each side by 5,000. And so I'm going to move things over a little bit, switch sides. R is what? 400 over 5,000. Let's mark away like what? 2 zeros here, 2 zeros here. 4 over 50, I believe we can divide both by what? 2. Yeah. Yeah. Well, actually, we want to go to what? A percentage. So if we got 4 over 50, that's the same thing as, we could do 8 over 100. So you could do that, or you could type it into your calculator. You could do 4 over 50. You could do that, whatever. Your calculator is going to give you 0.08 as a decimal, right? Okay. And so what does that mean? They want to know what the interest rate is. If you tell them 0.08, they're going to be like, they might know what you're talking about, but they might think that that's like 0.08%, and that's not what that's saying. What this is saying is that it is 8%. And so you might want to tell them it's 8%, right? And so I think the proper way to kind of enter this is that R is 8%. If they give you a word problem, they're going to give you the interest rate in percentages, right? They're not going to tell you R is 0.08. And so that, I think in response, you should probably also answer them in the same way that they're talking, right? And so I think if we write out a formula, maybe this might be one of the difficult steps, is like deciphering the English into the math, right? You might accidentally swap these things around. but this thing you should definitely get correct, right? There was only one time the aspect given there. So that's problem 2. And I think we just completed the first page. Let me shuffle some papers around. Okay. And so we got a bit of an introduction to percentages. And now we want to talk about percentage increase and decreases. And so this is sort of that thing where, depending what your base amount, you can kind of manipulate people into believing something is a better discount or than it really is, or maybe that a penalty isn't as bad as it is, right? And so what does this say? A hardware store offers a coupon for 10% off any item. What is the sell price of a set of drill bits whose original price is $19.95? Okay. So what do we want to know? What do they ask? They say, what is the sell price? So we don't know what the sell price is. We know the original price is $19.95, and we have 10% off. Okay. So if we take 10% off, this is a percentage, this is a ratio, right? And so I need to know a base amount to know what the heck this is even talking about. And so 10% off what? We're going to take 10% off. Well, the thing that we have to work with is the original price, which is the $19.95. And so this thing is my discount. Okay. And if you wanted to calculate it, I guess we can calculate it right quick. But my discount is going to be like what, $1.99.5 or 1.995, sorry. So half a cent in there somewhere, which they're not going to give you, right? So you better put that in there. Okay, so that your discount's going to be a little right short of $2. Okay. So we're taking that discount, and what are we taking it off of? What are we starting with? So we have to start with the original price. And so if we calculate this, this is going to give us exactly like what 17.955. And so you're going to end up paying $17.96 because they're not going to give you that half a penny. We're going to have to round that up, right? And so I see this. I see 1995 here. I see in 1995 here. There's really something I can do. I can put parentheses around this thing. And if I want to put a coefficient that doesn't really change this thing, I can. It's kind of silly, but I could like think of a 1 being out here. And so really there's another way we can think about this. If the original price is $19.95 and we're taking 10% off of that, one way we can think about that, and we haven't really gotten to factoring, but these both have the same factor of $19.95. And what we're left with in parentheses is 1 minus 0.10, right? Or 10%. You can think of it as, if you want to think about 1 as 1.00, this is 100% minus 10%. And so what we're actually doing, another way you can solve this is you have 1995, and you're taking 90% of that. And if you do this, you'll notice that you'll get that same solution. And so this is like taking 100 minus 10 will give you 90%, right? And so that's like 90% of the original 1995 will be 1796. Okay. And maybe one more thing about this is, does that seem maybe like reasonable? If we take 10% off of something that's 1995, if you've done enough shopping, yeah, you might be able to tell that that might seem a little bit reasonable, right? Just using like kind of real world context to check your solutions in these word problems uh, can be beneficial sometimes, right? Okay. So we took money off on this one. So this one was a discount, right? And so we're taking money off. If we read this one, like the first word on here, due to inflation. So I hope like maybe you're looking, inflation means things are going up, right? And so this one, we're taking things off the price. This one, things are starting to go up. So let's think about this one. Due to inflation, prices have increased 20% since 1995. What is the current price of a bookshelf that cost $239 in 1995? Okay, and so this is a very similar sort of structure. We're going to start with an original price. It's going to have an increase, and then we're going to end up at the current price, right? And so what do they want to know? They want to know the current price. They give us 20%, and so if we're doing 20%, as I said before, 20% as a ratio, we have to have a base amount. What are we taking 20% of? Well, we're taking 20% of the original price in 1995, which is 239. Okay. And so this is inflation, so that's going up by this amount. And so we're increasing or adding this amount to something. What is this inflation taking place on? Well, it's taking place on this original price, this 239. Okay. And so if we calculate this, if we take 239 and we added 20% of 239, you might notice there's a similar sort of pattern happening here, right? There's one of these 239s and we're adding another 20% of them. We can do the same sort of thing. So 100% plus 20% is 120% of 239. And so if you want to calculate it this way or that way, either way, you should be getting the same number. And the number you should hopefully get is 286.80. And so the current price of this thing is 286.80. And so does that seem about reasonable, going up by like 20% of 239? Yeah, probably something in there. I mean, not expecting you to know these things exactly, but it's not like saying it's $1,000, right? It's not going up from $239 to like $1,000 or something crazy that doesn't make any sense, right? Okay. And so that's a bit of work of percentages. I think we're going to switch gears just a little bit. And we're going to start doing like sort of first order linear sort of equations. And so here's the general problem solving strategies that they give you. So first thing you should do is you should define your variables, define them clearly, identify what the problem is asking for. So the thing that they don't give you and ask you for, that's usually your variable, right? This is usually a good choice for, I said it before reading that sentence, sorry. Create an equation is the next thing. We want to create some sort of equation with the variables. So first define the variables, then create the equation from those variables. And then the next step is actually doing the math, right? Solving, and then we should be able to go back and check and make sure when we plug our numbers, our solutions back into the equation, they form a true statement, right? Okay. So let's get started on number 7. Number 7. Yeah. So this may not make a lot of sense to people that are younger than me, but back when I was a kid and we used to go camping with the family, there used to be like bag phones that were about the size of a laptop, and you would carry these things, and there would be like some sort of either base charge, or they would charge you around like 25 cents a minute for any phone call you made, pretty much. Um, and I think that was like with the $10 base charge, maybe, or something. And so it was pretty expensive to make phone calls. When people became teenagers, the people my age became teenagers, I think most everyone, half the kids at least, probably like had some issue where they just racked up the phone bill, talked too much. So these are big things. What you didn't used to be where you just paid about 30, 40 bucks and then you had like an infinite plan. They used to charge you out the wazoo for it. And so, inspired by that nostalgia, is problem number 7. You are comparing two cell phone plans. One company charges $24.95 per month and 20 cents per minute. The other company charges no monthly fee and 45 cents per minute. How many minutes would you have to use to have... Wait, how did I read that yet? How many minutes would you have to use your phone for the two plans to charge the same amount? Please round your answer to the nearest minute. Okay. So what are they asking for? What's the one with like the question mark? They say how many, and then they give you that word, right? How many minutes? So what do we want to know? We want to know the number of minutes that you have to talk for these plans to be the same, right? And so our variable is the minutes. We want to know how many minutes. And so you can let your variable be X, Y, Z, anything you want it to be. And so M is the number of minutes. And they're charging these plans per month. So maybe if you want to say number of minutes talked per month or something, we are talking about per month here. Okay. And so now we want to think about equations. And so this is the sort of thing, it's what we call a first order linear. And so when we talk about first order linear equations, it's going to look very similar to what we're doing here. One company charges $24.95 per month and 20 cents per minute. And so if you want to think about the monthly charges for just this first company, $24.95 per month, 20 cents per minute, we're going to be charged $24.95 regardless of making any calls, even if we speak 0 minutes. So this is guaranteed. We're going to also be charged 20 cents per minute. So what does that look like? Well, it's 20 cents. And if I want to know 20 cents per minute and I want to know the total charge, this is like if we get charged, 10 cents per apple and we buy 10 apples, it's going to be $1, right? So if it's 20 cents per minute, we want to know how many minutes we're using. And so we want to know how many minutes. And so that's our M that we have to multiply by. And another indicator is that the word per means we're dividing by minutes. And so if this units, and we'll get to unit analysis later, but if this is being divided by minutes, this is dollars per minute, we have to multiply by unit minutes to get to the unit of dollars. And so when we study unit analysis, that will definitely make more sense. But just a heads up, you can also use a unit analysis to kind of look at these things and determine what gets multiplied. Okay, and so that's the first plan. And now I want to think about the second plan. It is 45 cents per minute. And so if you want to, grab a paper. Let's just think about this all in its own. So there is a $0 sort of base charge. Right in there. So they're going to charge you nothing to begin with. There's not that like 25 per month thing happening there. It's $0 base charge and 45 cents per minute. And this is the same sort of thing. It's the 45 cents per minute, so we need to multiply that by the number of minutes. Okay. And so what are they saying about these two plans? We have this plan. Ooh, can I get them both on here? Maybe not. Okay. We have this plan that charges you $24.95 per month and 20 cents per minute, and this that charges you 0 per month and 45 cents per minute. And so what they're asking is, when are these two things going to be the same amount? And so mathematically, we say two things are the same amount when they are equal. So we're asking, where are these two things equal? Okay. So I really don't need to write the 0, so I think I'm going to throw that 0.45m up here. So we want to know where these two equations are equal. Okay, so now we're solving a single variable first order equation. And so we have things, this has no variables, this has variables, this has nothing but variables. So this has nothing but variables, get your variables to one side. So I have to subtract 0.2m. I have to subtract 0.2m here. And this is going to give me something like what? 24.95 is going to be what? 0.25m. And so now I am dividing both sides by 0.25. And so this is 0.25 times m. To get solved for m, I got to divide. So divide both sides by 0.25. And so at this point, probably definitely want to grab a calculator and figure that thing out. It's a bit of a beast, but there you have it. 99.8 is the number of minutes. In the problem, that's really annoying. I don't like that. 99.8. They should have made the problem maybe a little better. But life is messy, and you don't always get even numbers. And so what are they saying? They say, please round to the nearest minute is the last sentence in that problem. So we have this thing 99.8. They're going to want they're going to want you to tell them 100 minutes. Okay. And so just a bit of a recap. We have a base charge, and we have this thing that's like 20 cents per minute. And so I kind of said it, but this is like kind of like a first order linear equation. So before we're getting to it, I want you to see maybe this is like my b. So I think I maybe shouldn't use the variable m, right? But this would be like my mx plus b. And that's why I'm saying it's like kind of like a first order linear equation, right? Same thing with this thing, right? If we look at this one, I can kind of dissect this one in the same way. This one would be like my b, this one would be like my m, and this would be my variable x. So this will have some sort of correlation to the stuff we do in the future. And if it seems like I'm throwing a lot out at you, fair enough. I'm not expecting you to know this. We'll have an entire section over that in the future. I'm just trying to get the symbols out in front of your eyes, maybe. And so let's do this last problem. So this problem, I feel like if you went out with your friends and did this, you may not have any friends left, but I don't know. Maybe they care about you more or something. I don't know. But you and a friend have lunch and share a bill of $35.50. If you paid 2/3 of the amount your friend paid, how much did each of you pay? So I know what this sounds like, and it's not what it sounds like. This says if you paid 2/3 of the amount that your friend paid. It's not saying that you paid 2/3 of the total bill. That would be really easy to figure out. This is not what they're saying. So you and a friend have lunch and share a bill of $35.50. If you paid 2/3 of the amount your friend paid, how much did each of you pay? So what do you not know? I don't know how much I paid. I don't know how much my friend paid. So I have two things I really need to figure out. So I could start my variable, and I could start it with either thing. But the easier one to start it out with, and I'll kind of explain it after I do it, I think. Let my x be the amount. So I really want to start with the amount the friend paid. And part of that is because now we can take 2/3 of this amount your friend paid. And we can define this thing as the amount you paid. And so we have the amount your friend paid. We have the amount you paid. And the other thing we know is that it was a bill total of $35.50. So how do we get to the bill total? Well, we have to take these two amounts and we have to combine them. We have to add them, right? And so we have to take x. We have to add the 2/3 x, which is the amount you paid. So the amount your friend paid, we're going to add that to the amount you paid, and that should give us the total bill of the $35.50. Okay. Now we're sitting with something. We got an x term, we got an x term, we got a number. These look like terms, but how do I combine these? So that might be something we might have to fill in a little bit. This is like a 1x. So I got 1x plus 2/3 x equals $35.50. Okay. So 1x is okay, but I have fractions, and I need to add these two things. And I want to do this real quick. If I want to do 1 and I want it as a base 3, that's 3/3. I don't want to spend a whole lot of time on that. But the same number over itself is going to be 1. And so anytime you have a 1, really all you have to do is take this and repeat it, right? So this is 3/3, and we want to add another 2/3, and that should give us the $35.50. Okay, so adding fractions. Now we're back to adding fractions. 3/3 plus 2/3. We want to keep the common denominator. We want to do the 3 plus 2 on top. So 3 plus 2 should give me 5. So I got 5/3 x is $35.50. Okay, and so now I have a fraction times my variable is equal to a number. So if I want to solve for this variable, this is multiplication. I want to make this 1x. There's a few ways to do it. I think the easiest, most direct is just to reciprocate this thing. Multiply by the reciprocal, that always gives you the 1. So if I multiply that side by 3/5, I better darn sure do it to that side. So both sides get multiplied by 3/5. And at this time, I'm not expecting you to do that in your head, definitely not. That's going to be 2130 if you grab your calculator. And so we're talking about a money amount here. So we have solved x. Woo! Are we done? No, not quite. What we got to go back. We got to talk about what the heck we were doing, right? And so if I know x would be what? The amount my friend paid. Okay. And 2/3 x would be the amount you paid. So this 2130, and let's write it out, is the amount that your friend paid. So they asked how much did each of you pay. So we have only gotten one of those things. The other thing we have to do is figure out what the heck is 2/3 x. So 2/3 x is what? 2/3. And if we plug in x, we figured out x was 2130. And so if we do 2/3 times 2130, I'm getting 1420. And so 1420 move it up. Okay, sorry. 1420 is the amount that you paid. Okay. So I figured out 2130 is the amount the friend paid. 1420 is the amount you paid. So then the other question is there some way to check this problem? So if we check the problem, we know that altogether we paid what, $35.50? So if we take 2130 and we add 1420, so if we take the amount your friend paid and we take the amount you paid, is it true that that is the $35.50? So this matches that previous equation I had. If we take those two amounts, is it true that it follows and that it actually adds up to the total bill? Absolutely, it should. Okay. And I think that will conclude the notes for today. Thank you for sticking around. Thank you for working through them. Continue to do a great job.